Hi everyone, hope you're doing well. This is a video to go over your review for your stats quiz that you're having this week. All these worksheets can be found on my website. And if you have any questions, please reach out to me. All right, here we go. Number one, what kind of correlation is shown by the data in the scatter plot? So as you can see, you have a couple dots here. They kind of go this way, which is showing positive slope, and we correlate. Now that means it's going to have positive correlation. All right, what kind of correlation is shown by the data? You can see they're all over the place. Dots are all over the place. So because of that, there is no correlation. Okay, this has positive correlation. This has no correlation. All right, number three, does the data on the scatter plot appear to have positive, negative, or no correlation? As you can see, the dots kind of go in this direction, kind of has a negative slope. Since it has a negative slope, it would be negative correlation. Number four, explain whether a scatter plot of the data for the following would show positive, negative, or no. So now you don't really have a graph to look at. You kind of have to figure it out with the words. So daily attendance at an outdoor carnival and the number of hours of rain. Okay, so think about it this way. The more it rains, what's happening to the attendance? Obviously, if it rains more, you're going to have less attendance. So this would be your hours here, and then this would be your attendance. And by the way, this word relationship, don't forget, that also means correlation or association. Remember, we could interchange those three words. So attendance. So as the hours of attendance go up, the hours of rain go up, the attendance is going to go down. So it's going to look like this, and that's going to be negative correlation. So again, as the number of hours of rain increases, the daily attendance decreases. So that would definitely be negative correlation. Okay, number five, the equation y equals 1.6x plus 2 represents a trend line. Remember, trend line is fancy for a line of best fit. Based on this, what is expected time it takes a commuter to travel 30 miles to work? So if you notice, most likely you guys would go ahead and draw a line and you're trying to figure it out, but 30 is not on this graph. So 30 is extrapolating because it's not inside the plotted values. So we're going to have to use that equation. You can't get it from your line of best fit because 30 is not even on this graph. So we want to plug in 30 in for x, right? Because this is the x value. This is your distance from work, 30 miles from work. And we're going to get 48 plus 20. Actually, this should be from work, not to work. Sorry about that. That should be from work. And then when we add them together, we're going to get 50. So it's going to take our 50 minutes. Okay, remember, again, 30 is extrapolating because it's outside the plotted values. So outside the plotted values. All right, number six, this scatter plot shows a relationship between the time walked and the number of calories burned. Based on this, how many calories would someone walking 60 minutes expect to burn? So now our x is 60 minutes. If you notice, 60 is inside the plotted value, so this is interpolating. So that means we can go ahead and draw our line. Notice there's no equation given. Remember, your line has to be somewhere in the middle of all these dots. So you try your best. 2, 3, 1, 2, 3. Okay, if I could do it kind of like this. 1, 2, 3, 1, 2, 3. Good enough. No arrows on this left side because no negative minutes or calories. All right, so if we go to 60 minutes, and so let me put no arrows, and we go up, okay, and we go over, okay, it's a little higher than 50, so maybe 150, I don't know, 155 calories burned. Okay, remember, it's going to be, a little bit of a, there's going to be a little bit of a range of numbers that they're going to allow you to use. Remember, this is interpolating because it's inside the plotted values. So just as long as you got something between like 150 and 160, that will be perfect. All right, next page. Number 7, in which one of the following is a trend line most helpful? Now remember, it says line, so just look for line of best fit. That's really what it's asking, right? Trend line is line of best fit. Which one means that line? And that would be C, linear association. Number 8, the scatter plot and trend line on a graph go from upper right to lower left. Okay, so upper right to lower left, like this. What does this indicate about the data? So if you notice, this is going to be increasing, okay? This is going to be a positive correlation. So the data are not accurate. The change in one set does not, nope. As one increases, the other, nope. Okay, so both of them increase. When we have positive correlation, both of them increase. All right, number 9. The scatter plot shows the ages of cars and their values in dollars. Draw a trend line to represent. Okay, so must be in middle of dot. Must be in middle of dots. So that's your most important thing. You want to make sure it's the best of your ability in the middle of those dots. Okay. Definitely notice that's a negative association, so make sure there's a negative slope. And then you want to make sure, so negative correlation, you want to make sure no arrows. You know, it kind of looks like it extends, sorry. So no arrows here and no arrows here. Because no negative age or money. Okay, no negative age and no negative money. Just make sure it's in the middle of the dots and make sure that you have no arrows. Okay, in question 9, so this question, does 5 years represent interpolating and extrapolating? So 5 years is inside your plotted value. Okay, because it's inside the plotted values. And as you can tell, we can use our line of best fit to get our answer. Unlike this first one over here, number 5, the 30 was outside the plotted value. So I couldn't use my line of best fit. I had to use my equation. So think of like maybe E with E, equation with extrapolating. That's how maybe you can remember. All right, number 11. The city mileage and horsepower of 10 popular cars are given in the following table. Do the data points represent linear or nonlinear? So I don't really see a curve at all. I definitely see, you know, a line. Oh, let me try to use this. Definitely see something that looks more like this, I guess. So I would definitely say linear. Remember, linear means line, not linear means not a line. Okay, and there's that word again, association. Also is correlation and also relationship. Okay, so definitely linear association. And then I want to know if it's negative or positive. Remember, negative is going to be looking like negative slope and positive is going to be looking like positive slope. Okay, so negative slope and then positive slope. So this, to me, definitely looks like negative association. All right, so far so good. Number 11, done. Okay, now we're on to number 12. Which of the following gives the best guess for 16 chapters? So 16 is interpolation. Okay. Sorry, I just need some more lead. Interpolation. So it's inside the plotted value, so you can use your line of best fit. So go up and go over. So again, I'm going from 16. I'm going up. Once I hit my line, I go over, and it's 160. Okay, so use line of best fit. Line of best fits when you are interpolating. All right, 13. What are the coordinates of the outlier? So you want to kind of see that all the dots are here together, and the one that is not like that is the outlier. So it looks like, or not near the plotted value. So 5 and 5, I think is close enough because it is not near the other plotted points. All right, 14, look at the table below. What's scatter plot is a graph representation? So basically you want to just graph the points. So just graph the points. This is your X, this is your Y, because money should be on the X, and see which one is correct. All right, so 5, 30, 10, 20, 15, 10. Oh, look, first choice. Yay, that's the only one that is correct. All right, 15. The scatter plot shows the number of students and the number of hours of homework they do in a week. how many more students do 2 hours of homework than 4 hours of homework? Okay, so remember, how many more? This is from our final. This is subtract. Okay, so we want to do 2 hours and 4 hours. Okay, so 2 hours of work. 2 hours of work, there's 50. So 2 hours equals 50 students. All right, and now what 4 hours is 30 students. 4 hours is 30 students. So if we subtract them, 50 minus 30 is 20. 16, look at the graph below comparing the depth of the water to the fill time. Which one of the following is the best guess for 8 minutes? So 8 minutes is inside. Okay, so this is interpolating. So what you want to use the line of best fit whenever you're inside. And then you're just going to, again, like the other one, go up to the line and then go over. And it's between 15 and 20, but definitely closer. Oh, so which one is it? Definitely closer to 15 than 20. So I'm going to go with B. All right, moving right along. Next page. Oh, this is our long one. All right, so this is our long one, but you got this. Don't worry. Noah researched the weekly high temperature in his city. He chose several weeks between July and December to put in the table. The first week of July was numbered week 1 in Noah's source material. Okay, so the first thing we have to do is use Noah's data to make a scatter plot. So just make sure that everything is done. You need your X and you need your Y. Those are labeled, so that's good, but definitely add the X and the Y. You have the zeros, and the only thing we need is our title. Remember, it's X versus Y, so just copy what they have. So weeks since July 1st versus the temperature in degrees Fahrenheit. Remember, this is called the break. The break just allows you to skip values. All right, so we have our X and our Y, and then we have our second X and our Y. So now we're just going to go ahead and plot those points. Okay, so 16 and 78, 25, 55, right? Because that's 0, that's 6, that's going to be 55. 3, and oops, that's not 100. 3 and 100. 17, which is between 16 and 18, and 65. Those go up by 5. 13, which is in between 12 and 14. 13. 75, right between 70 and 80 is 75. 5 and 90. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, that half is done. Next half. 12 and 78. 12 and 78. 7 and 95. 10 and 84. So a little below 85. 9 and 90. 15, which is between 14, 16, and 74, so a little below 75, and 21 and 62, so a little higher than 60. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. Yep, 6 and 6 is 12. All right, so that was the first thing that we had to do. We had to graph our scatter plots. All right, so next thing, what type of association is shown in the scatter plot? Remember, association also means correlation or relationship. All right, as you can see, I think it's pretty easy to see, it's negative. So we're going to have negative association. And then explain just means sentence. So remember, as X increases, Y decreases. So as the number of weeks since July 1st increases, the temperature decreases. All right, part C, you want to find your equation and round to the nearest 100. So remember, for the equation, we have to use the lowest and highest X values. Those are the ones you have to use, okay? Lowest and high. So go back to your chart, and your lowest, I can even see from here, it's going to probably be the 2. No, 3. Looks like it should be lowest. So 3. And your highest is going to be one that was 25. So they actually happen to be right next to each other. So this is your low, and this is your high. All right, so again, my lowest x value was 3. Actually, let me write this first. Keep it consistent. Y equals mx plus b, m equals b equals. Okay, so my lowest was 3, so 3 and 100. And then my highest x was 25, and 25 was with 55. So we have x1, y1, x2, and y2. So you have your formula, y2 minus y1, x2 minus x1. And that's 55 minus 100, and then 25 minus 3. So that's going to give me 55 minus 100 is negative 45 over 22. And negative 45 divided by 22, we want to the nearest hundredth, so tenths, hundredths. So the 5 rounds that 4 up to a 5. And it is negative, which should make sense, right? We should get a negative slope because we said we had a negative correlation. And the same thing is like kind of having this negative slope. So that makes sense. So negative 2.05. All right, now we want to be consistent. And to get the y-intercept, you're going to use your first point, and you're going to use your slope. So we have x, we have y equals mx plus b. So you have 100. Your slope is negative 2.05, and your x is 3. So multiply negative 2.05 times 3, and you get negative 6.15. Now we do want to add. Most of the time we do subtract, but we do have to add this time. Remember, opposite operations, you want to do the inverses to cancel each other out, and that's going to give me 106.15. So if we put it all together now into y equals mx plus b, you put your m, negative 2.5 in with an x, and then you have your b, 106.15, and that is your equation. Now remember, you need the equation in order to do the drawing the line of best fit. So if it's ever opposite order, you have to do the equation first. And this is where you want to begin. Begin here. Okay. So you want to go to where 106 is, or approximately where 106 is. It's about right here. Don't put an extra dot. Okay, you cannot have an extra. You can only have the 12 that are up here. So put the extra dot and then try your best to get it in the middle. So let's see, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Maybe a little lower. A little lower. Okay, let's try this. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. That's good enough. 5 on one and 6 on the other. All right, so you want to make sure you think about arrows. Can I have negative weeks? Can I have negative temperature? No. So no arrows. Okay, I can't have them going this way, and I can't have them going that way. So no arrows, no negative weeks or temperature. Hopefully you're noticing that if it's ever a negative slope, there's no arrows at all. If it's ever a positive slope, there's just an arrow on the top. That's usually how it works. Okay, and then don't forget to put your equation, because that's really important. All right, part E, use your equation to find the temperature at 11 weeks since July 1st. Check your answer by looking at your graph. Okay, so use your equation means literally copy your equation. So whatever equation you got, you want to copy. And usually they're telling you to plug in. So 11 weeks, was it the X or the Y? Which one was weeks? Well, weeks are right here in your X. So you're going to plug it into the X. So negative 2.05 times 11 and 106.15. So let's multiply. So we have negative 2.05 times 11, and that's going to be negative 22.55. So negative 22.55 plus this really big number, plus 106.15, gets me 83.6. So 83.6 is 83.6 degrees. So let's see if we're anywhere close. So let's interpolate. So we have 11 weeks. If we go up, we get to our line, and then we go over, yeah, I would say that's pretty close to 83, right? This is 85. So good job. Good job. All right, does the 11 weeks from part E represent interpolating or extrapolating? So I basically just said it. Because that it's inside the plotted values and you can use your line of best fit, it's interpolating. So interpolating because 11 weeks falls inside the plotted values. Okay, so you can I'm going to write can use line of best fit to get answer. Okay, because that's really what it is. You can use that line of best fit to get your answer. All right, we got one more question, and this is what we spent our last couple days on, and this is our two-way table. So a random sample of 8th grade students was asked if they like skateboards, snowmobiles, or both. Complete the two-way table. Remember, you can start whichever way you want first. You want to start a column or a row, it is up to you. I'm going to start a column. So this is your total. So 125 minus the one piece of information will get you the other piece of information. So 45, okay? I don't have enough here. I don't have enough here. And we have to have at least only, you have to have minimum just one empty. Let's put it that way. All right, let's go this way. So I have my total. I have one of the two pieces I need, so I'm going to subtract. So 105 minus 80 is going to give me 25. All right, when I have the two pieces of information, I want the total. Total means to add. So 45 plus 10 is 55. Okay, I don't have enough this way, so I can go back this way. 25 plus 10 is 35, and 105 plus 55 is 160. So really whatever order you want to do, it's not wrong, just as long as you get it right. So this is going to be a total for the table, and that's going to always represent how many is surveyed. So when I ask how many students were surveyed, you're going to give me that number right there. All right, relative frequency. So basically you're going to be making a fraction, and we want to know of a student who likes skateboarding and snowmobiles to all the students surveyed. So there's that word to. Remember, if you have of and to, you have both of them, you always defer to this to tell me what my denominator is. So all the students surveyed, that's going to be your denominator. And again, that's who is being surveyed. And then your numerator is what you want to know about them. I want to know students that like skateboarding and snowmobiling. So that is your numerator. All right, so all the students surveyed. How many students were there all together? 160. So out of the 160, how many of them like skateboarding and snowmobiling? So snowmobiling, skateboarding, 80. That's 80 over 160, which I think reduces. Remember, 80, ABC, 160. Yep, 1/2. Always reduce it if you can. And that is your answer. All right, a couple little extra things before I let you go. 3 little vocabulary words that'll help you for your quiz. First one is bivariate data, okay? Bivariate data. And that is a set of data that involves 2 variables, okay? And that is the, that's the thing that's gonna help you out too, because prefix bi means 2. So set of data that involves 2 variables, okay? Then you have the outlier. Remember, that's a data value not plotted near the other dots. Okay, and we kind of went over that in a question before because you'll have to give me one of those tomorrow. And then cluster, this will always be in the extra view, a group of data plotted close together. And we'll go over that in our extra view tomorrow. Just when the dots that are plotted, I don't really have any good examples, but you know, you have a bunch of dots that are really all close together. That's going to be a cluster. All right, hopefully this helped. If you have any questions, please reach out to me. Make sure you are scanning all of these, or at least sending me pictures of all of these pages to count as your credit for doing your review. All right, any questions, please let me know. Have a great day.